sine inverse of sine 3 pi over 4. Now, there's a couple of different ways that we can go about doing these problems and thinking about them and using some shortcuts here and there. But I'm just going to go through all of these problems the same way. And that way you won't have to remember when the shortcut works and when it doesn't, and accidentally use the shortcut in a situation where you're not supposed to, and then end up getting the wrong answer. Okay, so just like finding the f of g of x that I just did, I start with this inside part. I need to find sine of 3 pi over 4. Well, I can use my unit circle. Remember, the sine is my y value, so I've got square root of 2 over 2. And when I'm looking at this part right here, I'm not looking at an inverse function, so I'm not restricted here. This is square root of 2 over 2. And now I want to find the inverse of that. That's where I go through those 3 steps, being sure I'm in the right quadrant.
Remember that when you're looking at inverse sine, you're going to be either in quadrant 1 or quadrant 4.
I'm no longer over here at 3 pi over 4. I'm over at quadrant 1 or 2. And because I have a positive value, I am in the first quadrant. Remember that the sine value is associated with your y value or your y coordinate. So this is going to be this point right here, and that's angle pi over 4. And that's the appropriate angle name. If I'm in the first quadrant, I'm okay with that. Okay, problem 2. Sine inverse of sine pi over 3. Again, I can start off, I need to start off here with this inner part. Finding the sine of 5 pi over 3. I can just use this inner circle or my unit circle here, get square root of 3 over 2. For my point there. So sine inverse square root of 3 over 2. Well, when I'm looking at the inverse, I'm looking at either quadrants 1 or 4. And because I have a positive value here, I'm at quadrant 1. So this is just going to be pi over 3 to the answer. Now, if you think about, inverses, this pi over 3, the first quadrant, we're in the domain of sine of theta, obviously. And we're also in the range of inverse sine. So those two do just sort of cancel out and give me what I started with. Let's look at cosine inverse of cosine 4 pi over 3. Okay. I'm starting off with this inner part here, cosine 4 pi over 3. Cosine of 4 pi over 3 is going to be associated with this x coordinate of -1/2. So I want to find the cosine inverse of -1/2. Now, right now I'm down here in quadrant 3, but cosine inverse is not in quadrant 3. I remember that inverse cosines, I'm restricted to quadrants 1 and 2. So I need to find a negative 1/2 here in quadrant 2 that's going to match up with what I need. Does that make sense? And you need to be sure that you're looking at the correct coordinate. Do I need to be looking at the x coordinate or the y coordinate? I'm looking at the x coordinate of negative 1/2 here, and that is going to be 2 pi over 3, and that is the correct name for that angle. All right. I want to see if y'all can figure this one out on your own. Sine inverse of sine pi. Okay, sine pi is going to be 0. So I'm looking at sine inverse of 0. So what sine value is going to give me 0? Remember that when I'm looking at my inverse functions, my first step is to be sure that I'm in the right quadrant. So sine inverse is restricted to quadrants 1 and 4. I can't be over here at pi. I want a sine value within one of these two quadrants that's going to have a value of 0. And again, sine is associated with the y value. So I'm actually at angle 0. If I was in degrees, it would be 0 degrees. I'm in radians, it's 0 radians. Questions with that so far? Okay, problem 5. Now we're going to get into something that looks a little bit different here. Because I'm going to have a sine and cosine mixed together in one problem. Again, still starting off with this inner part here. I'm just looking at my unit circle and figured out the cosine of 3 pi over 4. And remember, I'm not looking at inverses right now, so I'm not restricted here. So there's 3 pi over 4, and the cosine is the x coordinate, so negative square root of 2 over 2. So I have inverse sine of negative square root of 2 over 2. Right? So now I'm looking at inverses. Now I'm back to those 3 steps where I have to, first of all, figure out what quadrant I'm in. Or anytime we're doing the inverses, I'm doing these 3 steps here. And sine inverse tells me that I'm either in quadrant 1 or 4. So I'm no longer over here at, where was I? 3 pi over 4. I'm no longer over here. Right? I want a y value that is negative. So I'm going to be down over here in quadrant 4. And I have a y value of negative square root of 2 over 2, and that's associated with the angle 7 pi over 4. 7 pi over 4 is not my answer. My last step in this is to be sure I name the angle correctly. So I have to be sure that I keep this within my domain. Let me see if I can find my picture that I had for sine. I'm dealing with sine or cosine. I'm dealing with sine. Okay, remember that with my restricted sine function, I'm only going from negative pi over 2 to pi over 2. I can't go out to 7 pi over 4. Okay, if I kept going down here, I'm going to have y coordinate of negative square root of 2 over 2, and that's going to match up with some angle over in here. This angle of 7 pi over 4, I just need to rename it to where I get to that same landing point, and that's going to be negative pi over 4. Does anybody have any questions on how? And let me say again that when you're doing your homework, you need to be doing this part without your calculators, because on your test, you're going to have to do this without your calculators. You need to practice like you play, as they say, right? Okay. Problem 6. I have tangent inverse cosine of negative 1/2. Right, so starting off with the inverse cosine. So I am starting off this time with something that is being restricted. So I have to be sure that I'm in the right quadrant. And when I'm looking at my cosine functions, I'm restricted to quadrant 1 or quadrant 2. And if cosine is negative, I'm going to be over here in quadrant 2. Right? So I know what quadrant I'm in. And I want an x coordinate of negative 1/2. And that's going to be associated with 2 pi over 3. So I want the tangent of 2 pi over 3. Does that make sense so far? Well, the tangent of 2 pi over 3 is not on my exact value chart. So I have to go back to what I know about finding tangent. It's opposite over adjacent, or y over x. Tangent of theta is y over x. So in this case, what was that? 2 pi over 3, square root of 3 over 2 over negative 1/2. And that simplifies to negative square root of 3. Now you could use reference angles to figure that out if you want to, but I think most people are going to be more comfortable doing it this way. Okay. Let me give y'all a minute to try this problem on your own. Okay, this is going to be the cosine of negative pi over 4, and that should be square root of 2 over 2.